Circuit analysis, example C. First thing you want to do is simplify these diagrams. We look for the parallel and the series components here. In this particular problem, the 10 and the 30 are in parallel. We'll combine them by using the 1 over r equals 1 over 30 plus 1 over 10. So r combined for those two in parallel is 7.5 ohms. Draw the new diagram. Looks like this. It's supposed to be 100 volts, and 20 ohms is still 20 ohms, and then we have 7.5 ohms here at the top. And now those are in series, so we draw our new diagram combining those, and we end up with this simplified diagram, a total circuit resistance of 27.5 ohms. We've simplified this circuit, 100 volts. Once you get there, what you'll be doing is using Ohm's law over and over and over again. In other words, V equals IR. Starting with that last diagram, we have 100 equals the unknown current from the battery times 27.5 ohms of resistance. So I from the battery is 3.6 amps. So we know that. The units are all in the table up here. We fill that in, 3.6 amps. That was 100 volt battery. Now keep in mind our basic principles, and that is in series, all the components in series have the same current, which means they have different voltages. But in parallel, they have the same voltage but different currents. So looking at this diagram in the lower left over here, bottom left hand corner, I just drew this blue arrow here on my example. That blue arrow represents the same current flowing in this diagram, these two simple diagrams. That's the 3.6 amps. In other words, this 20 ohm resistor on the bottom left here is right by the battery. It's in series with the battery. It has 3.6 amps of current flowing through it. And this replacement resistor, the 7.5 ohm resistor, also has 3.6 amps of current. In other words, anything in series has the same current. The 100 volt battery, the 20 ohm resistor, and the 7.5 ohm resistor. So basically, we know that the 20 ohm resistor has 3.6 amps of current, the same as the battery because it's in series with the battery. The other two resistors are in parallel with each other. Combined, if we put them together, they're 7.5 amps. That 7.5 ohm resistor is in series with the 20 ohm resistor. It has 3.6 amps. Well, what we're going to do now is for the 20 ohm resistor, calculate its voltage, because we know once again V equals IR, and I'll be doing this on my calculator. If I plug into that for that 20 ohm resistor, looking down here on the lower left, I know R and I know I, V equals IR. I multiply 20 times 3.6, and I get a voltage of 72 volts for that particular resistor. I'll write that down. I was just using Ohm's law, V equals IR. So that's my voltage for that resistor, 72 volts. And then for the 7.5 ohm resistor, which is a helper right now, it's not an actual resistor, but it's connected to the 10 and the 30 ohm resistor, using V equals IR, I get 27 volts for that resistor. Now that resistor, the 7.5 ohm resistor, is really a combined 10 and 30 ohm resistor. Replace those two. Those two are in parallel. Those both have the 27 volts. I can go up to the top here. They're both 27 volts. They're not 100 volts. If the 20 ohm resistor was not there, they would both be 100 volts, but they're both each 27 volts. They're the same voltage as each other. They're in parallel with each other. So we can fill that in the table, 27 volts for each of those. And now we can use V equals IR to calculate the current in each one of those. So I'll do that off to the side. I'm just plugging into V equals IR for each of those 10 and 30 ohm resistors, because I know they're each 27 volts. I'll do one for you. 27 volts equals I times the 10 ohm resistor. So I is 2.7. amps. And if you do the same thing for the other resistor, you get 0.9 amps. So for the 10 ohm resistor, you get 2.7 amps. And for the 30 ohm resistor, you get 0.9 amps. So what's happening here is the battery is pushing current, and if I go to the original diagram, of 3.6 amps, 3.6 amps gets here to this spot. Let me call that point A. When the current gets to point A, more of it goes to the smaller resistor. In other words, 2.7 amps of current goes across this middle branch, say to point B. It's 2.7 amps, but then the 0.9 amps goes around the top through the top resistor. In other words, 1/3 as much because it's 3 times the resistance. And then back from point B around this way to point A again through the battery is the 3.6 amps. And once you have all those numbers filled in, you can just calculate the power by either P equals VI, which is probably the way you want to do it, or P equals I squared R. So I'm going to do that with my calculator, and the result is, for the 10 ohm resistor, 73 watts, 259 watts, a lot of current there. That's going to be the brightest bulb if it were a light bulb. 24 watts, and then the battery is 360 watts. That's the power supplied. The resistors or light bulbs would be using it up or giving it off as heat or light. And what you'll notice, if I take these three numbers, these three powers, that's 356 watts of output power. And if you round that off to 2 sig figs, it'd be 360 watts. So that's consistent with the battery supply of 360 watts.